Hello, welcome to CET 4884. In this session, we will continue addressing security technology. At this point, we learned about protecting companies' network through firewall technology, but what if there was an intrusion? How can we detect that? Now, remember that the firewall will not allow um, the hacker to get in, or an attack to get in, or an intrusion to get in. But what if the intrusion is already in? Then we need other methods that can mitigate, that can detect, and that can control the organization information. So this session will address different prevention and detection methods. People and technical controls are equally important in the protection of organization assets. Educating the people and implementing the technical controls should adhere to companies' policies and rules. All controls and training programs are trying to prevent intrusions. An intrusion is a type of attack on information assets in which the instigator attempts to gain entry into a system or disrupt the normal operations of a system, with almost always the intent to do malicious harm. So what if an intrusion happens? Then an incident response plan has to be implemented, identifying and classifying the intrusion, then responding and recovering from the incident. Incident response is frequently discussed in terms of prevention, detection, reaction, and correction. Intrusion prevention consists of activities that seek to deter an intrusion from occurring. In addition, it consists of procedures and systems that are created and operated to detect system intrusions. So intrusion reaction encompasses the actions an organization undertakes when an intrusion event is detected. Intrusion correction activities finalize the restoration of operations to a normal state, and by seeking to identify the source and method of the intrusion in order to ensure that the same type of attack cannot occur again. And of course, the intention is to return to intrusion prevention, thus closing the incident response loop. So the intrusion detection system detects a violation of its configuration and activates an alarm. System administrators can choose the configuration of the various alerts and the associated alarm levels of each type of alert. With the current equipment, it can send for you a text, it can send for you an email, it can even call you to alert you about some kind of an intrusion. So many IDSs enable administrators to configure the system to notify them directly of trouble via those different tools or via different approaches. So the IDS systems can also be configured to notify an external security service organization of break-in. Intrusion detection systems include a site policy that has rules and configuration guidelines governing the implementation and operations of IDSs within the organization. The ability to modify the site policies in reaction to environmental activities is called site policy awareness. When intrusion occurs, an alert or alarm will indicate that the system has been attacked or still under attack. Alarms could be triggered by false attack stimulus or true attack stimulus. False attack stimulus is an event that triggers alarms and causes a false positive when no actual attacks are in progress. False negative, the failure of an IDS system to react to an actual attack event. The false positive, an alarm or alert that indicates that an attack is in progress or that an attack has successfully occurred when in fact there was no such attack. True attack stimulus is an event that triggers alarms and causes an IDS to react as if a real attack is in progress. In some cases, the system will experience an ongoing activity from an alarm events that are accurate and noteworthy but not necessarily significant as potentially successful attacks. Such a case is called noise. So it can create some kind of a noise but not important to react to. The system can use alarm filtering process to classify the attack alerts that an IDS procedures in order to distinguish or sort false positive from actual attacks more efficiently. Actually, identical alarms that happen at close to the same time can be grouped into a single higher level alarm in a process called alarm clustering and compaction. The ability to detect the attack has a percentage of error. The value associated with an IDS ability to detect and identify an attack correctly is called confidence value. In other words, how much are the calculation confident that there is an attack on the system? Why to use an IDS? What's the importance of using intrusion detection systems? Why do we need those kind of systems? We use IDSs to prevent problem behaviors by increasing the perceived risk of discovery and punishment for those who would attack or otherwise abuse the system. Detect attacks and other security violations that are not prevented by the other security measures that we had before, like firewalls. Detect and deal with the preamble or preambles to attacks. Document the existing threat to an organization. Act as quality control for security design and administration, especially of large and complex enterprises. Provide useful information about intrusions that do take place, allowing improved diagnosis, recovery, and correction of causative factors. As been stated previously, we have three types of intrusion detection methods: a network-based, a host-based, or application-based systems. A network-based IDS is focused on protecting network information assets. The host-based version is focused on protecting the server or host's information assets. The application-based model works on one or more host systems that support a single application and is oriented to defend that specific application from special forms of attack. The host IDPS examines the data and files stored on host and alert systems administrator of changes, while network IDPS examines packets on network and alert administrator of unusual patterns. The next few slides will address in details how each type works, including the advantages and disadvantages. So a network-based IDS resides on a computer or appliance connected to a segment of an organization network and monitors network traffic on that network segment, looking for indications of ongoing or successful attacks. When a situation occurs that the network-based IDS is programmed to recognize as an attack, it responds by sending a notification to administrators. When examining the packets transmitted through an organization network, an IDS, which is the network IDS, looks for attack patterns within network traffic, such as large collections of related items that are of certain type, which could indicate that a denial of service attack is underway, or the exchange of a series of related packets in a certain pattern, which could indicate that the port or a port scan is in progress. The network IDSs are installed at specific place in the network, such as on the inside of an edge router, from where it's possible to watch the traffic going into and out of the particular network segment. The network IDS can be deployed to watch a specific grouping of host computers on a specific network segment, or it may be installed to monitor all traffic between the systems that make up an entire network. The network IDS uses signature matching to determine whether or not an attack has occurred or may be underway. Most of the time you have like a signature that comes with the attack. So if there is an attack underway, then you can actually determine if that attack has been occurred before, and you know that signature. So the network IDSs look for attacks patterns by comparing measured activity to known signatures in their knowledge base or database. They do this by comparing captured network traffic using a special implementation of TCP/IP stack that resembles the packets and applies protocol stack or application protocol verification. In the process of protocol stack verification, the network IDSs look for invalid data packets. In application protocol verification, the higher order protocols are examined for unexpected packet behavior or improper use. Some of the advantages of the network IDSs, it's good network design and placement of network IDS devices, which can enable an organization to use a few devices to monitor a large network. So it depends on how you put those devices within the network, but you can use just few devices to monitor the whole network. For the network IDSs, they are usually passive devices and can be deployed into existing networks with little or no disruption to network operations. All what you need is to select certain points and then plug in those devices, and you should be fine. You don't have to worry about any disruption of the network. Also, those devices are not usually susceptible to direct attack, and in fact may not be detectable by attackers. Some of the disadvantages: the network IDS can become overwhelmed by network volume and fail to recognize attacks it might otherwise have detected. So it might skip some of the attacks. The network IDSs require access to all traffic to be monitored. Also cannot analyze encrypted packets, making some of the network traffic invisible to the process, and it cannot reliably certain if an attack was successful or not. Some forms of attacks are not easily discerned by the network IDS, especially those involving fragmented packets. Part of the network intrusion detection and prevention system is monitoring the wireless network traffic and activities. There are many issues associated with the wireless network, such as physical security, the sensor range, the access point and wireless switch locations, and the wired network connections, and of course cost. The intrusion detection examines network traffic in an effort to identify problems related to the flow of traffic. Some of the events that could be detected through network behavior are denial of services attack, the TCP port scanning, the worms, the unexpected application services, and policy violations. The host-based IDS resides on a particular computer or a server known as the host and monitors activity only on that system. The host IDS are also known as system integrity verifier, as they benchmark and monitor the status of key system files and detect when an intruder creates, modifies, or deletes those monitored files that we have in the system. The most host IDS work on the principle of configuration or change management, which means they record the sizes, locations, and other attributes of system files. So basically, it's monitoring the files more than the network and the traffic on the network. The host IDS triggers an alert when one of the following changes occur. File attributes change, a new file are created, or existing files are deleted. The host IDS has an advantage over the network IDS in that it can usually be installed in such a way that it can access information that is encrypted when traveling over the network. The host IDS relies on the classification of files into various categories and then applies various notification actions depending on the rules in the host IDS configuration. With the classification, you can actually classify files as most important or highly classified to medium classified to low classified. The managed host IDS can monitor multiple computers simultaneously by creating a configuration file on each monitored host and by making each host IDS report back to the master console system, which is usually located in the system administrator's computer. So you can use the server to monitor other computers, and those computers will be reporting to the server for any alerts or any file changes or file configuration. The advantages of the host IDS: it can detect local events on host systems and also detect attacks that may elude network-based IDS. The host IDS functions on the host system where encrypted traffic will have been decrypted and is available for processing. The use of switched network protocols does not affect the host IDS, and the host IDS can detect inconsistencies in how applications and systems programs were used by examining the records stored in audit logs. The disadvantages of the host IDS is that it poses more management issues since they are configured and managed on each monitored host. So basically, since we are using it on individual computers, it will cause some management issues. The host IDS is vulnerable both to direct attacks and to attacks against the host operating system. The HDIS is not optimized to detect multiple host scanning, nor is it able to detect scanning of non-host network devices such as routers or switches. It is actually susceptible to some denial of service attack. It can also use large amounts of disk space to retain the host operating system audit logs to function properly, it may require disk capacity, to increase disk capacity to be added or to add to the system, and to make sure that the capacity is enough for all these logs that's being audited. The host IDS can inflict performance overhead on its host systems, and in some cases it may reduce system performance below acceptable levels, and it can slow down the machine extremely or drastically. So we need to make sure that that machine is or has the capacity and capability, the RAM and the processing capabilities to keep that system optimized or the performance up to the required level. So that will be all for this session. If you have any questions, please feel free to ask. Thank you and have a great day.